Alright, hi everybody. We're working through the trigonometry review here, and the goal of this question here is to determine the maximum and minimum points, the concavity and points of inflection for each of these. So the expression we're looking at here is the sine squared of x minus x over 2 on the interval 0 to pi. So, again, notice that this is a sine function here. Sine is defined over the entire domain, so for sure it's going to have no problems over 0 to pi. And in addition, x over 2 is just a polynomial function there, and again, it's going to have no issues over 0 to pi. So, essentially, there's nothing to concern ourselves with when it comes to whether or not there's a point in the domain and how that affects the critical numbers. So really, all we got to do here is just jump in and take the derivative. So in this case right here, because it's a sine squared, I got to take the derivative of the squared portion of this first, which will be 2 sine of x, and then the derivative of sine of x will be cosine of x. Okay, and then the derivative of x over 2 is going to be negative 1/2. Okay, now I'm going to set this equal to 0. There's no place where this is undefined, and so that's not going to be an issue, but we're going to find out the critical numbers by setting it equal to 0. And I'll bring that 1/2 over to the other side. So 2 sine of x cosine of x is equal to positive 1/2. Now we might be tempted to divide by 2, but actually, if you notice right away that this is an identity, this is actually a far easier question. This is equivalent to the sine of 2x is equal to 1/2. Okay? And so that actually simplifies this question quite a bit, because now I'm not fighting with two different trig functions here. Now I've only got the one. Now sine of x is going to equal 1/2 as long as 2x is going to be equal to, now remember this is going to be in quadrants 1 and 2 here. So as long as this is going to equal pi over 6, okay, or 5 pi over 6. Now, the next two of these, next two solutions are going to be like a full half rotation beyond that, because of the horizontal stretch that's going to occur here. So these really will be the only two solutions that I need to concern myself with. If I divide by 2, I'm going to get x is equal to pi over 12 and 5 pi over 12. Okay, and so now let's just take a quick look here. If we take a look at along the number line, starting at 0, our two numbers here are going to be pi over 12 and 5 pi over 12, and then out here to pi. Oops, sorry, can't see those. There you go. Let's just take a look at what our derivative is going to do. Okay, well, between 0 and pi over 12, okay, 2 sine of x cosine of x, well, I mean, this is, right here, this is less than, for example, pi over 6. And so what's going to happen here is these are both going to end up being positive. If I plug that in, any number in here, that's going to end up being positive. Cosine is going to end up being positive. Now the question really is that going to be less than 1/2? Well, the easiest way to think about that is now to just jump down to here. Okay, bear in mind that if you multiply pi over 12 by 2, pi over 12, looking at this right here, by 2, you're going to get pi over 6. Sine of pi over 6 is 1/2. And if I bring the 1/2 over, I'm going to get 0. Now, if I'm less than that, then what's going to happen here is I'm going to get a sine value that's less than 1/2. Minus 1/2 means this is going to end up being negative. Okay? If you choose a value between pi over 12 and 5 pi over 12, okay, for example, like let's just say, what do we got there? I was going to say, if I do 4 pi over 12, okay, 4 pi over 12 is really just pi over 3, okay. If I plug pi over 3 into this right here, I get sine of 2 pi over 3. That puts us in the second quadrant, okay. That's going to be essentially 60 degrees in the second quadrant. Now the sine of 60 is going to be root 3 over 2, which is bigger than 1/2. So when I subtract those, this will end up being positive. And then when I go into this section right here, between 5 pi over 12 and pi, and we might, for example, choose, 6 pi over 12, just for argument's sake. 6 pi over 12, or pi over 2. 2 times pi over 2 would be 2 times, I don't know why, my brain just fills a lot on that, pi. Sine of pi is 0, minus 1/2 is negative. So My intervals here of increasing, decreasing are going to be negative, positive, negative. And just so that you understand, again, if you're a little bit confused by what I was doing there, essentially what I was doing is evaluating this expression, but I was making this the sine of 2x minus 1/2, and then just plugging in numbers into this thing just to see what it is that it's doing, whether this is positive or negative, because that's the derivative there. So now I know that I'm going to get a minimum at pi over 12, and I'll put this up here. Okay, we're going to have a minimum at pi over 12, and I'm going to have a maximum at 5 pi over 12. Okay. Now, I still want to figure out what the y coordinates are, so I got to go back to the original function. Okay. Now, this in this case right here is going to require a little bit of calculator work, and I'll be honest with you right now, I don't have my calculator handy. So what I'll do is I will evaluate that in a little bit, and then I'll plug those numbers in. But that's kind of besides the point. Now we can move on and take a look at concavity. To understand the concavity, I got to take the second derivative of this. So y double primed is going to equal. Now, if you treat this as if the derivative here was the sine of 2x minus 1/2, the derivative is a little easier. The derivative of sine of 2x is going to be the cosine of 2x times 2. Okay, and then the derivative of negative 1/2 is just going to be 0. So the second derivative becomes 2 cosine of 2x. I'm looking for the points of inflection ultimately, but to do that I got to figure out the concavity, the changes in concavity. So I'm going to set this equal to 0, divide by 2, and I'll get the cosine of 2x is equal to 0. Okay, that is going to occur at 90 degrees and at 270 degrees, or 3 pi over 2. So 2x can equal pi over 2, or 3 pi over 2. Now, beyond that, I don't really need to worry about it because I'm going to be outside the given domain. I'm going to divide by 2 to get pi over 4 and 3 pi over 4. Okay, so now I'm going to take a look at this interval right here between 0, pi over 4, 3 pi over 4, and pi. And once again, I'm curious about what's going on here. If I choose a number less than pi over 4, okay, when you multiply pi over 4 by 2, you're going to get pi over 2. So this little section right here really amounts to that first quadrant. And we know that cosine is going to be positive in the first quadrant. If you choose a number between pi over 4 and 3 pi over 4, let's just say, for example, 2 pi over 4, pi over 2. If I plug that in here, 2 times pi over 2 is going to be pi. Okay, cosine of pi is negative 1, times 2 is negative 1, so this is going to be negative. Okay, and that corresponds essentially, if you think about this and transform it by that stretch, this is basically giving us between pi over 2 and 3 pi over 2. And from 3 pi over 2 out to pi, if I plug pi into that, okay, I'm getting 2 pi, okay, basically the full circle. In that last quadrant here, cosine is positive. So my intervals of concavity, this thing is going to be, just kind of cancel that out there from the previous question. This is going to be concave up on the interval 0 to pi over 4, union 3 pi over 4 to pi. And then it'll be concave down at from pi over 4 to 3 pi over 4. So the concavity is changing around these points. So my points of inflection will be at pi over 4, comma, I don't know, and then 3 pi over 4, comma, I don't know. And again, I don't have my calculator handy. I mean, I could figure that out relatively quickly from this, but you know, I'm going to have to do a lot of that work anyway in the calculator for the previous couple questions here. So what I'll do is I'll put those on there and I'll provide those on the website.